from. Finger on the pump, make the 6 straight jump from SoCal. Hollywood to the slums, chronic.
Oh, no problem. I'm glad you were able to come.
I really like your dress. It looks stunning on you. What are you wearing today?
Oh, thanks. Well, I'm wearing Canada LaBouche's custom-made dress, as you can see.
Well, those are fabulous designs on your dress. How are you able to make those perfect measurements of those shapes? That makes this dress unique.
Well, I'll have Canada come over and talk to you about it since she's the one that designed it. Let me call. Canada?
Okay, thank you.
Canada?
This is ABC News. But anyways, tell me about how you came up with those great ideas.
To tell you the truth, they were Angelique's ideas. I was just responsible to make her ideas a reality, and let me tell you, it was not easy.
Oh, it sounds very complicated, but I still want to hear more.
Well, if you want, you can give me a call, and I will give you all the details about it.
Okay, thank you. ABC will be glad to hear that. Thank you so much. Hello, Miss Canada? Hi. I wanted to know if today would be a good day to sit down and have an interview to talk about Angelique's dress. In 2 hours? Okay, that's fine. Bye.
2 hours later.
Hello, welcome to ABC News. Today I will have a sit-down interview with Canada LaBouche. So hi, thank you for coming to the interview.
Thank you for having me.
You're welcome. So how did trigonometry come into place when you did the dress?
Well, actually, many don't know this, but trigonometry is used a lot in the fashion industry. For example, the measurements of the model have to coincide with the measurements of the fabric. If not, the dress won't fit right.
Oh, okay. That's so interesting. I actually did not know about that, about trigonometry.
And did you also know that the very first textile machine was made in the era of 1764?
Oh yeah, isn't that called a spinning jenny?
Yes, and they actually designed a dress using sine, cosine, and tangent. Let me show you an example. See, this dress has 5 triangles, and when I made the cut, I needed to make sure that whatever I did on one side, I had to do to the other side. So whatever measurements were used in this adjacent side and this opposite side, I would have to do the same to the other so it would be proportional and fit the model exactly.
Oh, okay, thank you. It was a pleasure having you here.
Thank you for having me.
The model has a waist of 200 millimeters. The cut must be at a 35-degree angle to accommodate the model's body. Distinguish how long the cut must be in order to correspond with the length of the torso and the waist. So first we're going to underline our important information, which is 200 millimeters. The cut must be at a 35-degree angle, and we're looking for how long the cut must be. After underlining all the important information, we know that the waist is 200 millimeters, and to simplify this problem, I separated the triangles into 2 separate ones. To make this problem easier, I'm using the variable A to represent the torso and variable S to represent the cut. For our first triangle, we're solving for the variable A, which represents the cut, and we're given the waist of 200 millimeters. Knowing that, we know that A represents our opposite side and 200 millimeters represents our adjacent side. So we're going to use tangent 35 degrees equals A, which is our opposite, over 200 millimeters, which is our adjacent. Since we're looking for A, we're going to multiply both sides by 200, so 200 tan 35 degrees equals A. Once we plug that into our calculator, we know that A equals 140.042 millimeters. Now that we've found the length of the cut, if the designer would want to know how long the model's torso is, then she would simply use tangent. We use tangent because we were given the opposite and the adjacent, so tangent 53 degrees equals S over 200 millimeters. Since we're looking for S, we're going to multiply both sides by 200, and S equals 265.408 millimeters. Let's just say the designer wants to know how much fabric should be left over. The designer would simply subtract A from S, so 265.408 minus 140.042 equals 125.366 millimeters, and that's how much fabric should be left.